Hi everybody. In this video we're going to be taking a look at double replacement reactions, how to recognize them, and how to predict what their products are going to be. So let's take a closer look at the pattern. We start off by having two different compounds, and they're going to switch around a little bit to form two new compounds. We can see this pretty clearly by looking at our example. The first element, lead, or the positive ion, is going to be combining with the second element of the second formula, which is the iodine. That's the anion, the negative ion. And then the positive ion from the second compound combines with the negative ion from the first compound. So essentially you're just combining outers and inners. Let's look at what we have to do in order to predict these types of reactions. So in predicting, we're going to have to combine the outers and inners. When we form the new compounds, we're always going to put the metal first. And don't forget to balance out the charges. Since we're going to be forming ionic compounds, you should be doing T-charts. Let's try this out with an example. Okay, so for our example, we're going to combine the outers and inners. It means that copper will be combining with thiosulfate, S2O3, and then sodium will be combining with the nitrate. Let's start writing out the formulas. First we need to do a little resizing so that we have room. Before we combine the outers and inners, some people may be a little confused as to where these two compounds break apart. In other words, for the copper 2 nitrate, what is the positive ion, what's the negative ion? Now, with there being three different elements there, that means that there's going to be a polyatomic ion present, and polyatomic ions are generally going to be the anions or the negative ions. So it's going to be the last two elements that are going to be comprising the polyatomic ions. There's only one positively charged polyatomic ion that I can think of, and that is the ammonium ion, or NH4+. And so if that's not present in the compound, then look at the last part of the formula to identify your polyatomic ion, because it'll be an anion. Another thing that can help you out is the parentheses. The parentheses are always used for when you have more than one polyatomic ion, and so it makes it a little bit easier to see that the first compound breaks apart in between the copper and the nitrate. And the second one, if you didn't recognize S2O3, that is a polyatomic ion called thiosulfate. So when you're combining the outers and inners, you're going to be combining copper with thiosulfate, and you're going to combine the sodium with the nitrate. So here are the two formulas. We have Cu, S2O3, and NaNO3. Now before we move on and start working on trying to balance it, we do have to check our formulas to make sure that we have balanced off the charges. If we go back to our first compound, the copper 2 nitrate, we're going to have to figure out whether it's the copper +1 or the copper +2 ion that's being used. Since each of the nitrate ions has a charge of -1, and there are two of them in the formula, that means that the copper is going to have a charge of 2+ for this compound. So our T-chart for the copper 2 thiosulfate is going to have copper with a 2+ charge. Thiosulfate, S2O3, has a charge of 2-, and so we just need one of each of those ions in order to balance out the charges. We'll also do a T-chart for sodium nitrate. Sodium is a 1+, and nitrate, or NO3, has a charge of 1-, and so again we do not have to add any subscripts in. Our last step is just going to be to do some balancing, and so it looks like we just need a 2 in front of NaNO3 and then we're finished. So this one's kind of a complicated one for the double replacement reaction. We had to first combine the outers and inners, and so we combined the copper with the thiosulfate, and for the inners we combined the sodium with the nitrate. When we wrote the formula for the second compound, we made sure that we kept the sodium, which was the metal, listed first, And we always have to balance off the charges when we do ionic compounds. So we checked and made sure that we didn't have to add any subscripts. Once we have the formulas written, that's our skeleton equation, and then the last step is balancing. Let's try another example. So before we start to combine the outers and inners, let's make sure we know how to split these two compounds up. The last two elements that are in the first formula, Mn and O4, make up the polyatomic ion. It's called permanganate. And we have the parentheses in the second one giving us a clear indication that we're going to split that one up right there. So that's going to give us K combining with NO3 and cobalt combining with the permanganate. We have KNO3 and we have cobalt with the permanganate. So let's do some T-charts. For KNO3, we have charges of 1 plus and 1 minus, so there will not be any subscripts needed to be added. In cobalt, we have to figure out what the charge is by looking at our original compound. And since nitrate has a charge of -1, we could see that here. And there are 2 of those in the formula, that means cobalt must have a charge of 2 plus in order for the charges to have been balanced. And we also have the permanganate, which has a charge of 1 minus. So we are going to need 2 of the permanganates and 1 of the cobalts. We do have to add some subscripts. That'll require us to use parentheses around the MnO4 and put the 2 outside. So this gives us our skeleton equation, and now we can just go through and do some balancing. We'll just work left to right. It looks like the potassiums are balanced. The permanganate ion is not. I'll need to put a 2 in front of KMnO4 to balance off the permanganate ion. That means that the potassium is no longer balanced, so I'll put a 2 in front of KNO3 to balance off the potassium. And then I think if you check, everything else is balanced.